We're on lesson 39, unit 7-3 of the pre-calculus book, page 437. We're talking about sum and difference identities, and let's talk about the reason we need them first of all. If I said, what is the sine of 30 degrees, you would say 1/2. If I said, what is the sine of 60 degrees, you would say square root 3/2. If I said, what is the sine of 120 degrees, you would say, well, 120 degrees is in quadrant 2. It's 60 degrees from 180, so its reference is 60. So sine 120 is square root 3/2. It's in quadrant 2 where sine is positive, so it's also square root 3/2. But if I said, well, what is the sine of 75 degrees? You would say, we didn't memorize that one. But then I could say, yeah, but we could rewrite the sine of 75 degrees as the sine of 30 degrees plus 45 degrees, and we did memorize those. But you can't just take sine 30, sine 45, and add them together. The sine of 30 plus 45 expands into sine 30 cosine 45 plus cosine 30 sine 45. And so you got to find 4 pieces to get the final answer. Okay? So let's just finish this one, just as an example, and then we'll do the worksheet. And so sine of 30 plus 45 expands into sine A cosine B. So sine 30 degrees cosine 45 degrees plus, see the plus sign in that? We're right here, sine 30 cosine 40 plus sine cosine 30 sine 45. I said 40 instead of 45. So then cosine, first one 30 degrees, sine, second one 45 degrees. So sine 75 is the same as, you have to come up with 2 things. You could have said 90 minus 15, but you don't know 15. You could have said 60 plus 15, but you don't know 15. And so you had to use 2 things you do know, 30 and 45, to get your 75. And then we see what the sign of a sum expands into. It expands into sine first, cosine second, plus cosine second sine, or cosine first, sine second. And then we know what this is. What is the sine of 30? 1/2. This is all memory work from your unit circle from long ago. What is the cosine of 45? Square root 2/2. What is the cosine of 30? Square root 3/2. What is the sine of 45? Square root 2/2. Now we have to deal with radicals. We have 1/2 times square root 2/2, which is square root 2/4, right? That's multiplying this part. And then we're going to multiply this part, and we're going to get square root 6/4, right? You multiply first. Now we're going to add, the name is the same. You can't add square root 2 and square root 6, so you get square root 2 plus square root 6 over the common denominator 4. So the sine of 45, the sine of 75 in simplest form is square root 2 plus square root 6/4, but we need to think about quadrants. What quadrant is 75 in? 2. Sine is what in quadrant 2? Positive, so our sign is correct. It's in 1, I'm sorry. Sine 75 is in quadrant 1, and sine is positive in quadrant 1. And so square root 2 plus square root 6/4 is the simplified answer to sine 75 degrees. Okay? Let's see if we got that. Okay. So, to the worksheet we go. That was just to getting you introduced to how come we need it and how to use it. And now we'll go to the worksheet on 39 and 40, and we'll do question number 1. Question number 1 is sine 165 degrees. Now what we need to do is use a sum or difference to make that 165 be two things that we know the rule for in our head from our unit circle memory work. Okay? So what's two things that we can figure out that 165 came from? Well, we could do 135 and 30. We could do 145 and 120. We could do 45 and 120, right? Well, you may say, well, both of those add up to 165, so that's two different ways we could have gotten there, right? Now, let's think about this. What is the reference angle for 135? 45 degrees. Reference angle for 120 degrees? 60 degrees. So we had a couple of options there. Doesn't really matter which one you use, okay? But you need to remember sine 135. You got to think about what quadrant am I in and what's the sign, positive or negative, you see? Okay, it's not going to really matter. So let's just use the first one because that's what y'all said. I used the second one in my teacher's edition, but that doesn't make a difference in my worksheet key. Okay, so how do you expand the sign of a sum? Well, we're right back to here again. So we're going to have sine of first, cosine of second, plus cosine of first times sine of second. The sign of a sum expands into sine of first, cosine of second, plus cosine of first, sine of second. It goes sine, cosine, cosine, sine, plus, plus. Remember, sine kind of follows a plus, and cosine kind of, that's calculus. I'm sorry. you didn't know that. Forget I said that. I jumped into calculus all of a sudden. Okay. Oh, forget I said that. Here we go. So anyway, you can just memorize those or look them up. How's that? Now, the sine of 135, the reference angle is 45 degrees. So what is the sine of 45? Square root 2 over 2. What quadrant is 135 in? 2. Is sine positive, negative in quadrant 2? Positive, so it's positive square root 2 over 2. And we have cosine 30. What's cosine 30? Square root 3 over 2. If you don't know these answers, you need to study your unit circle. Cosine 135, what's the reference to 135? 45. And so cosine 45 is square root 2 over 2. Very good. And sine 30 is 1/2, but cosine 135, what quadrant is that in? 2. What is the sign of cosine in quadrant 2? Negative. This is a negative square root 2 over 2. I almost went past it and let it go by me. Always check your quadrant to check your sign. Very important. Okay, now order of operations, right? We got multiplication, addition, multiplication. We're going to do both multiplications first. Over here, we're going to get square root 6 over 4. Over there, we're going to get minus square root 2 over 4, right? Now we're going to do the subtraction. So we subtract the numerators. They're not like terms, so we leave them as the expression square root 6 minus square root 2 over the common denominator 4. Any questions on number 1? You can see the value of these sum and difference identities as we don't know what 165 is, but we can split it into things we do know and actually get an exact answer rather than punch it in the calculator and get a rounded answer. Okay? Any questions on number 1? I'll let you catch up. We have to know how to do fractions and radicals. If you don't know how to do fractions and radicals, it's not very nice at this point in pre-cal. Okay? Anybody need help on number 1? Everybody good? All right, number 2. Number 2, we have cosine of negative pi over 12. Now, do we know something over 12? Let's go back to our reference here. We know pi over 2 goes with what? 90 degrees. And we know that pi over 4 goes with 45 degrees. And we know that pi, I should have done pi over 3, let me back up. We know that pi over 3 goes with 60 degrees. And we know that pi over 4 goes with 45 degrees. And we know that pi over 6 goes with 30 degrees. So we like 2's, 3's, 4's, and 6's, right? Our memory work are 2's, 3's, 4's, and 6's. But we have a 12, but 2, 3, 4, and 6 are all factors of 12, right? That means since the denominator is 12, and 2, 3, 4, and 6 are multiples of 12, are factors of 12, excuse me, I could split that 12 into things like 3/12. Now what if I made a 3/12? What's that? A fourth. What if I made 2/12? A sixth. What if I made a 4/12? A third. You see what's going to happen? I really want to split it into something that's going to reduce to a half, a third, a fourth, or a sixth in the denominator, because that's my reference angles. So what can I do with that 12ths to end up with 1/12? How could I end up with 1? Well, 4 of them minus 3 of them, or 3 of them minus 4 of them, excuse me, it's negative. 3 of them minus 4 of them, right? Well, 3 and 4 are good numbers because 3/12 and 4/12 reduce. So I'm going to split this into 3 pi over 12 minus 4 pi over 12. 3 of those minus 4 of those is negative 1 of those. And I did that because I knew in my mind that 3 over 12 was going to reduce to what? Pi over 4. And I knew in my mind that 4 over 12 was going to reduce to 3. And now I've got stuff that's over here, you see. Okay? See how we did that? You got to be a little creative. You got to know some fraction stuff. Now we have the cosine of a difference, which is this rule right here, right? We're going to expand the cosine of a difference. So you have cosine A, cosine B, sine A, sine B, with a plus in the middle. So we're going to have cosine of the first times cosine of the second plus sine of the first times sine of the second. Cosine first times cosine second plus sine first, sine second. You might notice here on sine we got a plus plus. On sine we have a minus minus. On cosine you have a plus minus. On cosine you have a minus plus. In calculus, when we take derivatives, when we take the derivative of a cosine, it's a negative something. When we take the derivative of sine, it's a positive something. And that's what I was doing a while ago. I jumped into calculus class. The cosines have a sign change every time. It happens in calculus, it happens in trig. In these expansions of these sum and difference. Anyway, so now we want the answers to this. Well, pi over 4 is 45 degrees. What's cosine 45, or what's cosine pi over 4? Square root 2 over 2. And pi over 3 and pi over 4 are both in quadrant 1, right? So everything's positive this time. So we'll just go ahead and establish that fact. Now, what is the cosine of pi over 3? Well, that's like cosine 60, which is 1/2, plus sine of 45, or sine of pi over 4, is square root 2 over 2, times sine of pi over 3, which is like sine of 60, is square root 3 over 2. Again, if you haven't memorized your unit circle stuff, I said that every other step here, then you really got to do that. Now, we know that we're going to multiply before we add. So when you multiply the left, you're going to get square root 2 over 4. And when you multiply the right, you're going to get square root 6 over 4. And when you add the numerators, but they're not like terms, so you leave them as an expression, square root 2 plus square root 6 over that common denominator 4. Any questions on that? So cosine negative pi over 12 is square root 2 plus square root 6 over 4. Now, let's think for just a second. Is that really supposed to be positive? We did all that, but was it really supposed to be positive? Well, let's think about our quadrants. We're talking about negative pi over 12. That's going to be counterclockwise. It's going to be right in there. It's in quadrant 4. What about cosine in quadrant 4? It's positive. So we verified that it really is positive. Not bad to go back and check that, right? Okay. Any questions on number 2? Okay. So we had the sine of a sum. We ended up with a cosine of a difference. That gave us a couple of good ones to look at there. And so let's go take a peek at number 3. Number 3 says, find exact values if x is between 0 and pi over 2, which means it's in quadrant 1, and y is between 0 and pi over 2, which means it's in quadrant 1. Okay, so we got two angles. We're wanting to find the cosine of x minus y if cosine x is equal to 3 over 5 and cosine y is 4 over 5. Now, it says quadrant 1, so everything's positive. Now we got to get to our x, y's, and r's, right? You realize we got 3 separate things going on. We need to separate those in our mind. In cosine x, let's just treat this as if we don't see the cosine y. These are 2 separate entities. Okay? Cosine of x, cosine is what over what? Is it x over y, y over x over r, y over r? Cosine is x over r. And then we have the Pythagorean theorem, x squared plus y squared equal radius squared, right? And so we're going to have x, which is 3 squared, plus y, which we don't know square, is equal to the radius, which is 5 squared. We're going to get 9 plus y squared equal 25. Subtract 9. We're going to get y squared is equal to 16. Take the square root, and we're going to get y is equal to 4. You'll see why we need that. I can go ahead and start showing you now. We're going to expand cosine x minus y into this. And it's got sine and cosine. And all they gave us was cosine, so we have to find sine. And to find sine, we need the y, because sine's y over r, right? That's where we're headed with it. Okay? And so we're going to solve the second one. Cosine is x over r. So we're going to use the Pythagorean theorem. You realize the one on the right's a separate entity from the one on the left. Don't try to make the y of the one on the right be a y of the one on the left. Those are two totally separate entities. Okay? And so we're going to have x of 4 square plus y, which we don't know square, is equal to the radius, which is 5 square. And so we're going to have 16 plus y square equal 25. Subtract 16. Y square equal 9. Square root y equal 3. So the y of the situation on the left was 4. The y of the situation on the right is 3. This is what's important to us. I'm just going to highlight on x, when we're dealing with x. The x was 3, the r was 5, and the y was 4. We needed to know that. When we're dealing with angle y, the x was 4, the r was 5, and the y was 3. We need the x, y, and r so that we can find sine, cosine, tangent in a minute. Or just sine and cosine in a minute. All right, everybody see we got that? When we expand cosine of x minus y, we're going to be using the cosine of the a minus b, which is cosine first, cosine second, plus sine first, sine second. So we're going to have cosine x, cosine y, plus sine x, sine y. Right? Cosine x, cosine y, plus sine x, sine y. And then we want to put in our numbers. We got to be careful because we got two pictures going on. I should have used green and red or pink or something, but I'm going to use green for green, and over there where the yellow's at, I'll use red. Cosine x, cosine is what? Cosine is x over r. What is the x of the x one? The 3. What is the r? 4, 5, excuse me. And we already knew that cosine x, see right here? We already knew that cosine x was 3/5. We already had that. So cosine x is 3/5 times cosine y. They already gave us cosine y. It's 4/5 plus. Now let's go over here to the other side. Sine x. To get sine x, sine is what? Y over r. Sine is y over r, which is 4 over 5. And then I want the sine of y. Sine is y over r, which is 3 over 5. Everybody see we got all our numbers. And then we just multiply before you add. 3 4s are 12, 5 5s are 25. 3 4s are 12, 5 5s are 25. We have a common denominator of 25, so we can add 12 of those plus 12 of those is 24 of those little 25ths. Any questions on number 3? So you need to know that sine is y over r, Cosine is x over r. Tangent is y over x. Do the Pythagorean theorems. You have to know how to expand the sum and difference. And then you plug them in, and after that, you got to know how to deal with fractions. Okay? Any questions so far? Yes, sir. Okay. All right. Everybody good so far? Caught up? All right. Are we good? Okay. Number 4. Number 4, we have tangent of x plus y if cotangent x is 6/5 and secant y is 3 over 2. And again, we're going to think of these as totally separate entities. Now, cotangent is reciprocal of tangent. What was tangent? Y over x. Tangent is y over x. Therefore, cotangent is the reciprocal of that, which would be x over y. Tangent is y over x. Therefore, cotangent is x over y. So we're going to do the Pythagorean theorem here. X squared plus y squared equal radius squared. And so we're going to have x, which is 6 squared, plus y, which is 5 squared, is equal to the radius squared. So we're going to have 36 plus 25 is equal to the radius squared. And so we have 61 is equal to the radius squared. And then we take the square root, and we get that the radius is equal to the square root of 61. Do what? No. It was fun. The question was that necessary? And the answer is no. But it was fun. We're not ever going to need that r. But we could have expanded the tangent x and y and figured out we wasn't going to need it. But anyway, yeah, that was fun to do. Anyway, secant y, if we take secant, see it's all tangent over there. We're going to do it anyway, though, just for the fun of it. Secant is what? Secant is 1 over cosine. And cosine is x over r. So secant would be r over x. And I wanted to do it because I just wanted us to have to deal with reciprocating and getting these r's and x's. We just need the practice. Okay, so we're going to have x squared plus y squared is equal to the radius squared. So x, which is 2 squared, plus y, which we don't know square, is equal to the radius, which is 3 squared. And so we're going to have 4 plus y squared equal 9. Subtract 4. We're going to have y squared equal 5. Take the square root, and we get y equal square root 5. All right, so we found our missing pieces. And as was noted, when you expand tangent, you get all tangent stuff. And so on the first one, we had cotangent. To get tangent, all you have to do is reciprocate, so we didn't need the r. But on the second one, we did need to do the Pythagorean theorem because we needed to get the y, okay? Everybody see how we did that? I wanted us to go through the practice of thinking cotangent, reciprocal tangent, x's, y's, and r's, and get some practice there. Now, tangent x plus y. Tangent x plus y, we're going to expand using our plus b. And so what we're going to have is tangent x plus tangent y over 1 minus tangent x times tangent y. So we had the tangent of a sum, and so we look up our tangent of a sum expansion, and then we're going to plug into that. Now, the tangent of x, here's x. If the cotangent of x is 6 over 5, then what's the tangent of x? The reciprocal of that, 5 over 6. Now, the tangent of y. Tangent is what? Tangent is y over x. So tangent y is the y square root 5 over the x2. Over 1 minus tangent x. We've already figured that out. It's 5/6. Times tangent y. We've already figured that out. It's square root 5 over 2, right? So here's what we've got. I'm going to let everybody catch up, and I'm going to get rid of all that green stuff over there so I can have some room to do this fraction. Everybody good? I can erase all the green? I didn't even look. I hope so. What do you call it when there's a fraction over a fraction? It's called a complex fraction. To make a complex fraction not be complex, if you'll multiply the numerator and denominator by the common denominator of all denominators, it will simplify it a bit. So we're going to do that first. We've got 2's and 6's, and so I'm going to multiply the numerator by 12 and the denominator by 12, which is really a form of 1, and that's going to make it not be a complex fraction. It won't be a fraction over a fraction anymore. It'll be a whole number over a fraction. Okay? So when I do, I'm just going to do it up here just in case. We're going to have that 5/6 times 12, right? Everybody see that? 12 times the 5/6, which is going to give me a 10. Everybody okay with that? Plus, now when I do this part, I'm going to have square root 5 over 2 times 12. Right? That's this. Square root 5 over 2 times 12. And those reduce to a 6. And so I get 6 square root 5. That's my new numerator. There's not a fraction in the numerator anymore. That's better than it was. And then I'm going to distribute here. And I'm going to get 12 times 1 is 12. And this 12, you see this 12 right here? When I go 12 times this, it's going to wipe out that 6 and 2. And I'm getting up with a 5 square root 5. Is everybody okay with that happening? I multiplied this 12 by these two things, and that 12 wiped out the 2 times 6 on bottom, and I was left with a 5 square root 5. So by multiplying the numerator and denominator by the common denominator of all denominators, we went from a complex fraction to a normal one. Doesn't look real normal. But the problem we have now is a radical in the denominator. But it's a binomial situation. If you have a radical that's a part of a binomial in the denominator, how do you rationalize? You multiply by the binomial conjugate. So we need to multiply the top and bottom by the conjugate of the denominator, which would be 12 plus 5 square root 5. So to rationalize the denominator, we're going to multiply by the conjugate of the denominator. And whatever you do to the denominator, you must also do to the numerator. I'm going to have to clean house again. This one's going to take several boards worth of stuff. We're getting closer. All right. Now, remember, the denominator is going to be the difference between the two squares, right? It's going to be 12 square, which is 144, minus 5 square root of 5 squared. Now, 5 square root 5 squared is 25 times 5, because square root 5 times square root 5 is 5. So you're going to have 25 times 5 is 125. So you have 12 square, 144, minus 5 square root 5 square, which is 125. On the bottom, there's no radical anymore. You have rationalized the denominator. Now, when you actually subtract those, you're going to get a 19 for a denominator. That got a lot prettier. Everybody see how we got that? Now, we have to FOIL the top out, right? Firsts, 10 times 12, 120. Outers, 10 times 5 square root 5, 50 square root 5. Inners, 6 times 12, 6 square root 5 times 12, plus 72 square root 5. Lasts, 6 square root 5, I'll write that one down, 6 square root 5 times 5 square root 5, right? 6 square root 5 times 5 square root 5 is 30 times 5, which is 150. Square root 5 times square root 5 is 5, so plus 150. Whoops, that was not nice of it. This is a square root 5, if I can get it in there. Let me try to remember where it's writing at. Good. They see we got that. And so now we can combine like terms. 120 plus 250. 120 plus 150 is 270. 50 square root 5 plus 72 square root 5 is 122 square root 5, which won't simplify any further. And so the answer is 270 plus 122 square root 5 over 19. Any questions on number 4? Wow. That's about all the time we have for today. So we'll have to do some more lesson tomorrow to pick up number 5 and 6. Any questions on sines, cosines, and tangents of sums and differences? All right. So that's the answer. 270 plus 122 square root 5 over 19. Yes, sir.